In this video, I am going to discuss about the numericals based on electric resistance and Ohm's law. First question I am taking here. Suppose a wire of length L, area of cross section A, and its resistance is R. Will this wire be stretched? When wire be stretched n times. Wire be stretched n times means if earlier its length was L, then now its length becomes NL. Then what will be the new resistance? Then its new resistance, suppose this R dash, this becomes N square R. And already I have discussed this problem in the earlier video. Now, how can you solve one problem? Suppose I am giving you, how can you solve this one? By using this formula directly. Suppose a wire of resistance R. Suppose a wire of resistance R and length L. If its length be increases by 10%, it means if length B increases by 10%, then how many percent its resistance will change, or how many percent its resistance will come in? In this question, how can you find the answer? Why earlier resistance is how much here? Length L. Its length B increases by 10%. 10% means after stretching, suppose its length is L dash. So this L dash is equal to original length L plus 10% of L. 10% of L means 10L upon 100. 10% of L. So 10 100, and you will get L plus L by 10. And this becomes 11 L by 10. It means earlier its length was L. After stretching, its length becomes 11 L by 10. Then how many times after stretching this length be increased? So how you will get the value of N? It means in this case N is equal to, means how many times the length be increased? N is equal to, after stretching, what is length? 11 L by 10 upon initial length is how much? L. It means L is cancelled by L. How much you will get? 1.1. It means if a wire of length L, when its length B increases by 10%, then its final length becomes 11 L by 10. And how many times it will increase? 1.1%. Then what is the new resistance? Then new resistance R dash just becomes N square R. N square is how much? 1.1. So 1.1 whole square into R. Then you will get 1.21 R. But I am asking here, how many percent this resistance be increased? So percentage increase in resistance, is equal to, after stretching, what is the resistance? 1.21 R minus initial resistance R upon initial resistance R into. And I hope maybe all of you know how can you find the percentage change. So 1.21 R minus R. So you will get here 0.21 R upon R into 100. R is cancelled by R, and here you will get 21%. So directly you can find out if a wire whose length B increases by 10%, then how many percent its resistance B increases. So direct by using this concept you can find out the answer. Dear student, here I want to tell one thing here. When two resistors R1 and R2, I am talking only about the two resistors R1 and R2. And suppose both resistors R1 and R2 are joined in parallel, then direct their equivalent resistance we calculate. In numerator, we will take their product R1 R2 upon R1 plus R2. But this formula I am using only for two resistors when joined in parallel. And this you will get here same way, 1 upon R equivalent, 1 upon R1 plus 1 upon R2. By using this concept, directly you can use this R equivalent is equal to R1 R2 upon R1 plus R2. This question, which is very easy, and I hope maybe already have solved in the class 10, but here I want to discuss here. Suppose three resistors 2 ohm, 4 ohm, 5 ohm is connected between A and B in parallel with a cell of 20 volt. Our aim is to find what is the equivalent resistance of this circuit and what is the current in each resistor. And suppose this cell is sending the current I, and that current I will be divided in three parts. Suppose current in 2 ohm is I1, this 4 ohm I2, this one is, and in 5 ohm is I3. So first, how can we find the R equivalent? Direct, since all these three resistors are joined in parallel, so their equivalent you can calculate 1 upon R1 plus 1 upon R2 plus 1 upon R3. And when you will solve it, then simply you can say its LCM will come here 20. This one is 10 plus 5 plus 4, and you will get here 19 by 20. Means 1 upon R equivalent is equal to 19 by 20. So R equivalent is equal to 20 upon 90 ohm. Now at place of all these three resistors, you can put a single resistance of 20 by 90 ohm. And now potential of this battery or cell is 20 volt. So the current drop from this cell, I is equal to this V, means potential of this cell upon equivalent resistance. So you can say I is equal to 20 V upon R equivalent is 20 upon 90. It means this becomes 19 ampere. Unit must be there. Without unit in the board exam, you will get no any marks. So unit be always you should be. Now main current, this one is I is how much here? 19 ampere. This 19 ampere current we divided into how many parts? 3 parts. And how can you find the current in each part? Simply current in 2 ohm, which is I1, you can find I1 is equal to, all these three resistors are joined in parallel, and in parallel potential will remain same. It means this potential is 20 volt, so here potential will also 20 volt. Here potential also 20 volt. Here potential will also 20 volt. So how will you find the current in this branch? I1 is equal to potential difference across this one, which is 20 volts, since all these are in parallel. So 20 upon resistance is 2. So this becomes 10 ampere. Similarly, current in 4 ohm resistor, which is I2 is equal to, again potential difference across AB, which is 20 volt upon resistance 4, and this becomes 5 ampere. And similarly, I3 is equal to current in this 5 ohm resistance, I3 is equal to 20 upon this 5 ohm, I is equal to V by R, and this becomes 4 ampere. And I1 plus I2 plus I3 should be equal to I. Total I is how much? 19 ampere. And total sum of this I1 plus I2 plus I3 is 10 plus 5 plus 4. This one is also 19 ampere. It means the distribution of the current in each of these branches be correct here. In this way, you can also check your answer. Next problem, this third one. Suppose this one is very simple, both circuit is very simple, and our aim is to find the equivalent resistance between A and B. So between A and B, if you see all these resistances, then all these resistances are joined one by one. It means end to end. Second end of this resistance be connected to the first end of the second one, second end of the second one with the first end of the third one. It means all these resistors between A and B are joined end to end. And this is what it could be the condition of series combination. So in this case, R equivalent is equal to R plus R plus R plus R plus R. Which one is what here? 5R. 5R. This one. And suppose one more problem, which is here. Find the equivalent resistance between A and B. Our aim is to find equivalent resistance between A and B. But in A and B, you see, these two resistors are joined end to end. Here, these two resistors are also joined end to end. In same way, these two end to end, these two are joined end to end. It means these two resistances are in series. Their equivalent, you can put a single resistance of how many ohm? You can put here 2 ohm. And similarly, 2 ohm and 2 ohm both are in series. Their equivalent, you can write here 4 ohm. Similarly here, 1, 1, 2. So this one be also replaced by a single resistance of 2 ohm, and this one be also connected by a single resistance of 4 ohm. This one is also 2 ohm. Here also we can write this one is 2 ohm, this one is 4 ohm, 4 ohm, this one is 2 ohm. And again this one is 2 ohm and this one is 4 ohm, this one is last. So simply you can say 2 ohm, 4 ohm, both are in parallel. Their equivalent can be given as, what formula I have told you for the two resistances are in parallel. R equivalent you can find 2 into 4 upon 2 plus 4. It means 8 by 6. 8 by 6 means simply you can say this one is 8 by 6. So simple resistance of 8 by 6 ohm. Similarly, this one will also 8 by 6 ohm. This one is also 8 by 6 ohm. And this one is also 8 by 6. This point is 8 and this point is 8. And now they are equivalent. All these resistances between A and B are in series. So their equivalent are equivalent 8 by 6 plus 8 by 6 plus 8 by 6 plus 8 by 6. And now you will get here, this one is 32 by 6 ohm. Simply you can find R equivalent, you can also write this one is 16 by 3. So simply in this way you can find out the equivalent resistance of this circuit. Now third case, maybe many of the students face this problem. Also I have solved this problem in the capacitor. There we have taken at the place of RC. Suppose if any circuit is given like this one, and our aim is to find the equivalent resistance between A and B. So now you see here, this one is simply a connecting wire. There is no resistance. This one is simply a wire. And in this wire, suppose this point is A and this point is D. Both A and D are at same potential. So here A and D you can write together because both are at the same potential. Similarly, C and this point B are connected to this wire. And in this case, this point C and this point B are at the same potential. So this point C and B also you can write together. This is a very easy method. And now you see here, this point is A and this point is C. Between A and C, this one is R. This point is A and suppose this point is C. Between A and C, one resistance is R. Between C and D, again one resistance is R. Between this point C, this one is D, this CD, one resistance is R. Again, this point is D and this point is what here? Either you can say B or C. This point is D, this point is B. Again, one resistance is R. It means all these three resistors between A and B are joined like this one. It means all these three resistors are in parallel and their equivalent we can find out 1 upon R equivalent, 1 upon R plus 1 upon R plus 1 upon R. It means 1 upon R equivalent is equal to 3 by R. Or simply we can say R equivalent is equal to R by C. So this one is also very common and very easy problem where all these three resistors are joined in parallel. Now, next problem is like this one. One is like this. If any circuit is given like this, and our aim is to find the equivalent resistance, find equivalent resistance across A to B. It means across AB, your aim is to find the equivalent resistance of this one. So first you see, your aim is to find the equivalent resistance across AB. Now you see the other end like this one from it. Now for this one, AF and FE, these two resistors are joined end to end. It means these two resistors are joined in series. They are equivalent. At place of this 3 ohm and 3 ohm, you can write a single resistance of 6 ohm. Simply you can write a single resistance of 6 ohm. Now you see, this 6 ohm and this 6 ohm, both are in parallel. So their equivalent you can write 6 into 6 upon 6 plus 6. Already I have told you, if the two resistances are joined in parallel, then their equivalent you can find in numerator product and in denominator you will take their sum. So this one is 36 by 12. It means again you will get here 3 ohm. It means 6 ohm and this 6 ohm, their equivalent is how much here? 3 ohm. It means at the place of these two resistors, we can put a single resistance of how many ohm? 3. Now again you see, this 3 ohm and 3 ohm again joined in parallel and their equivalent series and their equivalent 6 ohm. So again you can say at the place of these two, you can put a single resistance of how many ohm? 6 ohm. And again this 6 ohm and 6 ohm both are in parallel. Again their equivalent is how much here? 3 ohm. So at place of these two resistors, you can put a single resistance of how many ohm? 3 ohm. Again you see this 3 ohm and this 3 ohm both are end to end. It means again 3 ohm and 3 ohm both are in series and their equivalent again how much here? 6 ohm. It means at this one we can put a single resistance of 6 ohm and again this 6 ohm and 6 ohm both are in parallel. So their equivalent 3 ohm, again at place of these two resistors we can put a single resistance of 3 ohm. And now you see, your aim is to find the equivalent resistance between A and B. Between A and B, these two 3 ohm and 3 ohm both are in series and their equivalent 6 ohm. So this one is how much here? 6 ohm. And now between AB, these two resistors are in parallel and their equivalent, that you can get here, are equivalent 6 into 3 upon 6 plus 3, and now you will get here 18 upon 9. So sometimes easily you can solve any resistors problem which is given like this one by taking resultant of any two resistors with the third one, and finally you can solve it like this. Now in this problem, suppose any circuit is given like this one, and our aim is to find the equivalent resistance between A and B. But if you observe this circuit here, to last this 2 ohm and this 2 ohm, actually our aim is to find the equivalent resistance across AB. Assume if this AB is connected with a source of current, then maybe the current will pass through this one, this one, this one, this one, and current in this portion and current in this portion. When the current will comes in this part and this part, then outside इसके बाहर कोई सर्किट कनेक्ट नहीं है, क्लोज नहीं है. It means this 2 ohm and this 2 ohm both are out of the circuit here. It means both are in open circuit, and in open circuit no current will flow. And dear student, always you remember this: a resistor without current, a capacitor without charge, and a human body without breath is useless. It will be never counted. In same way, this 2 ohm and 2 ohm both are in open circuit between A and B. So this 2 ohm and 2 ohm, no current will flow in it. So it is useless. It will be never counted in equivalent. So you can remove it. Now, between A and B, this one is closed with this cell, ABS. Now you see here, 2 ohm, 2 ohm, both are in series. Their equivalent 4. We can put a single resistance of 4 ohm. This one is already 4. This one is 4 ohm. Now 4 ohm, 4 ohm, 4 ohm. These three resistors are joined into in. So these three resistors are in series. Their equivalent you can put here 12 ohm. A single resistance of 12 ohm. Now 12 ohm and 6 ohm both are in parallel. Their equivalent you can find 12 into 6 upon 12 plus 6. It means 72 upon 18, and you will get here 4 ohm. It means at the place of this 12 ohm and 6 ohm, you can put a single resistance of 4 ohm. And again this 4 ohm, 2 and 2, 4, 2 and 2, 4. Then again you say here, this one is 4 ohm. This one is 4 ohm. And this one is 4 ohm. Again, all these three resistors are in series. Their equivalent 12 ohm. Again, we can put a single resistance of 12. Now, this 12 ohm and 6 ohm, again, both are in parallel. Their equivalent, again, you can find out the 4 ohm. So, this one is, we can put here a single resistance of 4 ohm. And now, between A and B, all these three resistors are joined into end. It means their equivalent is equal to 2 plus 4 plus 2. It means this one is A. And finally, the equivalent resistance between A and B is 8 ohm. So be careful about this one. If any resistance is out of the circuit, means if the resistance is not closed, then that resistance will be never counted in equivalent resistance. Now next problem is here. How can we find the equivalent resistance between A and B in this case. And for finding the equivalent resistance in this case, you see this one is simple a wire, and this one also simple a wire. It means at this wire at each point potential will remain same. So you can assume if this point is A, here also you can assume this point is A, this one is also A. It means this wire potential at these points is same. In same way, this point B, and this is also a wire, so your potential will also same B and B means at this wire the potential will same at each point here. Now you can see suppose this point is C. Our aim is to find equivalent resistance between A and B. So now you see here A, all this point is A, all this point is B, middle point is C. So all these three can be taken as this point is A, this point is B, and in between we take this point as C. This is the criteria A, B, and C. And now you see between A to C, 8 ohm. Between A to C, this one is 8 ohm. And again here this point A to C is 2 ohm. So this one is A to C, this one is 2 ohm. Again B to C is 4 ohm. Suppose this point is B. To this one is B to C 4 ohm, and again C to B 6 ohm. C to B, this one is 6 ohm. C to B 6 ohm. And now again you see A to B 3 ohm. So now this point is A, this point is B. You can say A to B, this one is 3 ohm, and now again this A to B 6 ohm. Sequence is this point A and this point is B. A to B, this one is 6. Now you can say these two resistors are in parallel. Their equivalent you can calculate. How can you find their equivalent? 8 into 2 upon 8 plus 2. And when you will take 8 into 2 upon 8 plus 2, you will get 16 upon 10. It means at the place of this one, you can put a single resistance of 16 by 10 means 1.6 ohm. So you can put a single resistance of 1.6 ohm. In same way, 6 ohm and 4 ohm both are in parallel. Their equivalent 6 into 4 upon 6 plus 4. So 24 upon 10. 24 upon 10 is at the place of this one you can put a single resistance of 2.4 ohm. Now 1.6 ohm and 2.4 ohm both are in series. Their equivalent you can write here how much? 4 ohm. So at place of these three you can put a single resistance of 4 ohm. Now between point A and B all these three are in parallel. So we can find 1 upon R equivalent 1 upon 3 plus 1 upon 4 plus 1 upon 6. Their LCM is how much here? 12, 3, 4, 12. 9.12. It is R equivalent you can find 12. And in this way you can find out the equal resistance between A and B. In this problem, the capacitor C, here a capacitor C is connected here, and for a capacitor C in DC case, when DC source is here, for any capacitor, its resistance is infinite. And when you will take the infinite resistance of this capacitor, when it is connected to the DC, then this infinite with the 4, total this becomes infinite. It means in this case, if any resistance be connected to any capacitor, then no current, no any steady current will take place in this circuit. It means no current will flow in this 4 ohm resistor, or you can say this is useless because no any current is going in it. So what current is given by this cell? Same current is passing through this one and return in the negative terminal. So in this case, what can you do? You can remove this circuit. It is useless for you. But in the case of DC, I am telling. And now this 3 ohm and 2 ohm both are in parallel. They are equivalent 6 by 5. And 6 by 5 is you can take 1.2. Now this 1.2 ohm and this 2.8 ohm both are in series. They are connected, both resistors are connected into India. It means they are equivalent 1.2 plus 2.8. This becomes here 4.5. It is equivalent resistance of this one is 4.0 ohm. And if anybody asks you what is the current drop from the cell, then you can see this current I is equal to V upon R. So V means 4 volt. And what is the equivalent resistance of the circuit? 4 ohm. And in this way you will get the current is obviously from the here. So dear student, here I want to give only one thing here. If any capacitor is connected with any resistors in DC case, so no current will flow through that resistors, or that resistor will be counted in open circuit. So please also you try to solve the numerical problem based on this series and color combination from your book or from the other book. And next time I will start the next chapter DC circuits and development. Thank you.